Hi everybody, it's Mrs. Graney, and today's lesson is going to be on navigation. Now, navigation is going to use much of what we've just studied: law of sines, law of cosines, angles, but things are just a little bit different in the world of navigation. First off, when you look at where the angles are, notice that 0 degrees is due north, 90-degree angle is due east, 180 is due south, 270 is due west. So that's the first difference. The angles are in a different spot and kind of going in a different direction as well. Okay, so we look at our angles and we start at 0 degrees is north, and then we go clockwise from north when we are measuring or sketching out our angles. In navigation, you're going to see the word bearing. And bearing is the horizontal angle, or the direction between one object and another object. Okay, so let's go ahead and let's take a look at this. So examples of navigation. The first thing says we have a plane that travels at a bearing of 135 degrees. So what we have to remember is that little angle chart at the top here. 0 degrees is right here, 90 and 180. So if we're looking at a 135-degree angle, it lands right here in quadrant 4. Okay, obviously a little bit different from what we were doing in our class. The second example says that hikers walked in the direction of 40 degrees west of south. So picture that they're walking directly south, and then you veer off 40 degrees to the west of that. Look what it says. 40 degrees west of due south. So that is a 40-degree west of due south angle. We can also write it like this, okay? And we say 40 degrees west of south. Okay, what that does for us is it gives us a 50-degree reference angle. Okay, just like in the first example, we would have a 45-degree reference angle. So that doesn't change because this is still broken up into 90-degree quadrants. The third example we have says a plane traveled 500 miles per hour for 2 hours. So first of all, 2 times 500, it traveled 1,000 miles. And it says it traveled at a bearing of 240 degrees. So notice what we do. Here's the starting point. 0, 90, 180, and here's 240 degrees, okay, for 1,000 miles. If you think about it, 240 minus 180, that gives us this 60-degree angle right here. Now, from here, so we make another little coordinate plane, thinking 0 degrees is right here, 90, 180, 270. It says that then it traveled at 450 miles for 90 minutes. So 450 times 1.5 hours gives us 675 miles. So that's where this came from, at a bearing of 310 degrees. So again, we're going to go, okay, 0, 90, 180, 270. So 310 is 40 degrees off of 270. So we start to form this triangle, and the question here said, how far is the plane from where it started? So that's where we connect back to where the plane started. Now let's just take a look at this, because in the directions up here, I told you parallel lines are going to come into play. And the reason I say that is we're going to have to work within this triangle. So if we look at this as being a 60-degree angle, we have line direction of the plane, and then northwest line again, that means that this is a 60-degree angle. We know that this is 40 degrees here, so 40 plus 50 gives us 90. So all of a sudden now we have side, angle, side, and we're looking for another side. So if we were actually trying to solve for this, we would use law of cosines. Think about that problem, see if you can make sense of it, and when you're ready, go ahead and try these 3 problems. I'd like for you to pause the video, try the problems, and then start it up again and see if your answers match mine. Okay, so let's take a look. I didn't quite finish C yet, so we'll get there in a second. Letter A, it said you were traveling at a bearing of 330 degrees. So remember, you're going around this way. 330 is 30 degrees shy of a full rotation. Letter B, it said the hikers were walking 20 degrees north of east. So you kind of think, all right, if they were walking north, they'd be going this way. So they were walking 20 degrees north of that. So that's your 20 degrees north of east. And on letter C, we were given a boat. It was traveling on a straight path on a bearing of 120 degrees. So again, we start here, here's 0, here's 90. 120 is 30 degrees past 90 degrees. So that's where the purple line segment is here. And it said that it traveled at 60 miles per hour for 3.5 hours. So that's how I got that this segment right here was 210 miles. It then turned. So automatically, when I know that it's going to turn, I know I'm going to have to figure out what direction it's going in. So I gave myself another coordinate plane. And it said it traveled until 5 o'clock at a bearing of 60 degrees. So again, I think, well, this is 0. 90 would be going this way. So 60 degrees is just in that first quadrant right here. 60 degrees is going this way. And it traveled at 60 miles per hour for 1.5 hours. So that's how I got that this segment was 90 miles long. Now the question is, how far is it from where it started? So the green segment represents that. Now I know we weren't actually asked to solve this, but we would have to piece a little bit more information together. So if we were going to solve this, we would need to know what this angle is right here. So let's remember, if this is 30 degrees, the supplement to that is the complement to that is 60, right? 30 plus 60 equals 90. And here's where we have those parallel lines. We have a bearing of 0, then we have the direction that the ship went, or the boat, and then we have here going this way again. So if this is 60, this is also a 60-degree angle. Okay, so we make those 2 different coordinate planes to help us. Now what we would have is that this, and I'm going to just sketch it over here just so you can see it, we actually have that 120-degree angle with one side that's 210 and one side that's 90. So again, we can use a law of cosines to figure out how far the boat is from where it started. Let's go to the next page. So what you have here on the next page are a variety of problems using what you just learned. So what I would like for you to do is go ahead and sketch the diagrams for all of these problems. I don't want you to work any out. I just want you to sketch the diagrams and submit your work. And once we make sure they are correct, we will go ahead and solve them. Okay? Have a great day, everybody.